before we'll jump into this topic, I think the previous topic which we learned that is related to consistency and which is linked with synchronous and asynchronous. So just have a quick recap that what we have seen in our last session. It's consistency, and as you know that this is mainly related to databases or data correctness, where we have seen the different types of it: strong consistency, eventual consistency, and weak consistency. And we also seen that what is the meaning of it, like strong consistency comes into picture where data similarity or correctness is more important. And because of that, we need to have data replicated to all replicas, and then we will respond back to web server. But in case of eventual consistency, we are seeing that we just send it back the response from primary database. The replica will be uh, copied the data to the replicas later on. And similarly for weak consistency. So we have seen this concept, and on the same line, we are going to look at the synchronous and asynchronous. So this is kind of architecture or maybe a step that we usually take during designing a system. And we need to understand what is the purpose of it or what is uh, the goal that we are trying to achieve through synchronous and asynchronous. So let's understand synchronous first. Synchronous, as I've just mentioned here again, the book definition. Synchronous is a blocking architecture or process where the execution of each operation depends on the completion of the previous operation. And each task required answer or acknowledgement before moving to the next iteration. So this is exactly what we have seen in the previous strong consistency, where we have to wait for the response or we have to wait till all the replicas are not copied with the latest information. Till the time the acknowledgement is not sent to the web server. So let's look at even that same example here again. But before that, we'll also see some key points where single thread. I've also mentioned strong consistency here. User have to wait for a response. Hence, sometime it's a little higher latency. I'm not saying very high, but a little higher. And it is tightly coupled. In the sense you see that unless and until everything is not done, you don't get any response. And there are chances if there are any failures during copying the data to replicas, we have to handle those. But this is an easy to code kind of scenario where it is just a sequential process that you need to follow and get a response. Okay. And I also mentioned some example. So telephonic conversation that we do, video conferencing that we do, or sometimes we play online gaming. These kind of things that where you need a response, a quicker response when you're talking to someone on telephone, and if you don't get response, you will be like, okay, the person is not available, or there is some a network issue or something. But you are looking for a response. Then only you will have a proper conversation with that person. Similar for the video conferencing. Unless and until you don't get response, when I'm talking to you all, and when I see that you are getting my, means you are able to hear me, you are able to see what I'm sharing to you, that is continuously going on. Like the data is transfer, you're receiving it, and I'm getting a response kind, like you're receiving that information when you ask question or something. And similarly, even for online game, like you are playing with your friend, an online game, and if you do some move and you are expected some other move from your friend, maybe if it is online chess that you're playing and you have done one move and your friend's supposed to do a second move, but if it is not done, then you will not able to move ahead in your game itself. So this is called a synchronous process, as the definition says. When you do one thing, you are expected there is some output, but until and unless that output you are not getting or the response that you are not getting, you will not able to move it. And that is called synchronous. See, the dictionary definition of synchronous is something happening at the same time. If you look at the definition, it's something happening at the same time or at the same speed. That is also one thing. But here also where what we are looking at is we are looking at if one process is done, we are waiting for a response. Once we get a response, we'll move ahead with the next process. And then this is kind of chain that is moving ahead. And what we have seen in last time when we are looking at the strong consistency, and we took an example of financial transactions, where we'll just look at here, where we are looking at, okay, we are sending a a request to primary database. Primary database will send, first it will write it to itself, and then it will copy that data to all the replicas. So here the step number two is saying data copied or replicated to all replicas. Maybe there are two, three, or 10 replicas are there. So until unless all replicas are not copied, the data, the latest data, there will be no response from replicas to the primary database. But once the data is copied, replica will send the acknowledgement to primary database, and then primary database will send that acknowledgement back to web server. And then only we'll get a response. Like user will be behind this web server who will get the response once all this transaction, all these processes are done, and then user will get response that yes, your uh, process has been done, or maybe your uh, requested information has been copied to all the location. But usually response is like okay, there will be a code which will be sent to user saying that maybe you have seen 200. Uh, the HTTP response with 200, which will usually say success or okay. So that response user will get it, and then your transaction will be done. So it takes some time, depends on system to system. Sometimes you get response very fast. So that's again, it depends on system to system, that how you have designed the system and how you would like to respond back. So I'm repeating myself that synchronous is a blocking architecture. Blocking means you have to wait for the response or acknowledgement to get. Otherwise, you will not move ahead. So that's a blocking part of it. Because until unless you don't get response, like until unless primary database don't get response, it has to wait until unless web server has to get a response from primary database. It has to wait to get that response, and that response may take some time. I'm not saying maybe it's not then minutes or hours you have to wait, but sometime you have to wait little longer than usual. This is the entire cycle which we follow in synchronous. But there are cases where you need synchronous processes. The reason that we have seen last time is the strong consistency, the financial transaction in which you are looking for getting all the replicas with the latest information. And in that sense, your system has to be synchronous. You have to get all these responses back until unless all the replicas are not replicated with the latest information. If anything goes wrong, your system will not available for certain time. Your system will giving you response by taking some more time. So that is possible. So that's why I mentioned user have to wait for response, hence high latency. High means not very high, I'm saying maybe you have to wait for a minute or something. But definitely strong consistency and synchronous is more related, where you have to do some kind of trade-off between latency and consistency. So this is called synchronous architecture. Going back to asynchronous, asynchronous is exactly opposite to it. Again, I'm saying that if you look at the dictionary definition, it's like something that is not happening at the same time. So what is synchronous, or sorry, what is asynchronous? Is the execution of one task isn't depend on another. Task can run simultaneously. Again, in this case, um, let's look at some key points. Because we are saying task can run simultaneously, we can use multi-threading. We can do some parallelism between multiple tasks, and user don't have to wait for the response from this another component of your system, so that it will be a low latency. I mean, speed will be higher, and eventual or weak consistency will be there for sure. Because see, you are not waiting for it. You are just moving ahead, like your system or the component is just moving ahead with the further process. Let's look at this example, then we'll get into the actual process itself. Here I'm mentioning about file transfer or email. See, once when you send an email, you don't wait for a response. immediate response from someone. You send email and you just start doing your other work, right? When you give response to email, you send that and you don't wait for it. After some time you receive a response, then you look at it and then accordingly you respond further. Or even file transfer, when you copy the file to one location to another, you don't wait for it. File is getting copied, you just go and do your other work as well. So you are not depending on the system to get complete. You are not waiting for the response to get immediately or file to get copied from one location to another location immediately. You just let the process happen. I will start doing something else. So you are not dependent on that process to get complete. So in this case, the system is loosely coupled. There is no dependency on one component to another component. The process is not on hold. You can make this process, asynchronous process will go on, but you just have to keep on doing your other stuff without waiting for the response itself. And but there are chances where you will not have consistency there, a kind of strong consistency. You have to see that there will be weak or eventual consistency. Things will happen over the period of time, not immediately. So here again, the diagram is explaining about asynchronous. What we are doing is from web server. I think this we have seen last time. Web servers is sending the write request to the primary database. Primary database will first write to itself and then immediately send a response to web server that, you know what, I'm done with the process. I have written the information to the database, and here is the response. And web server will send that to user. But in this case, the primary database will, once after sending the response, it will start replicating the data back to the multiple replicas. See, there are pros and cons for both these things. Here, the replica, when there is a read operation happening, the replica will not have immediate data or the latest data available with it. Till that time, it will send whatever data it is available with the replicas. So that response replica will be giving back to user, but it will not have the latest information. Once the primary database will write back to replicas, then only it will respond back with the latest information. So here, the eventual or weak consistency is possible, where replicas will respond with the whatever data available with it, not the latest data, because latest data is till the time the primary database is not writing that information to replicas. Replica will not have that data, but here primary database is sending the response back to web server immediately without having any replicas getting updated, right? So just again repeating here that asynchronous is a non-blocking architect where primary database is not waiting for replicas to get updated. Primary database is just giving the response once data is written to primary database, and it is just responding back. And even web server or user uh, will have that response immediately. But primary database will not wait for replicas to respond back or acknowledge whatever request that is sent it to it. So again, this kind of architecture is required sometime where you don't have to wait for a response. For example, see, this kind of process come into picture when the certain action or certain process which we do it in the back end is not that important. For example, we have discussed last time, the view count or the likes, number of likes or view count or comments. These are not an user is not depend on those. Those are, we can decouple from the system itself where this can be changed later on. See, the user which is buffering, sorry, the video that is buffering in YouTube channel, when you watch a video, the video is buffering slowly. So that required some kind of immediate response. But the likes, the counts, or the comments, they don't need to be there immediately. It's eventually it will be visible to you that you can see the count is increasing maybe after 5 seconds or maybe after 10 seconds. So we don't need to wait for that, or the video doesn't have to wait for it. Video should go on, and then later in some time the number of counts will increase. Maybe you will able to see some more new comments and all. So again, as I said, These are depend on system to system, where what kind of architecture that you're looking for. So every synchronous or asynchronous kind of architecture will have their advantages and disadvantages as well. Where synchronous, it will be give you latest information. There will be strong consistency, but definitely there will be a response delay. There will be a high latency, or maybe sometime it will hamper your availability also. But in asynchronous, you will have high latency, but you will not have strong consistency. You will not get the you will not get the immediately the latest information that is written to the database. Okay, so these are all trade-offs that we need to do when we design a system. We have to see, okay, we need a consistent, do we need a consistent information or consistent data? Okay, we need, then what kind of system do we do? We need a synchronous, asynchronous. So those thought process we have to do. And we have to see to it that when we are designing a system, this thought process is given to all the components of the system, and accordingly we should design it. All right. So I don't want to move ahead now. I think I would like to stop here.